So what's a linear relation again? Right, it's a relation that forms a line. Yep, that's it. Okay. Now, if you remember, when we were looking at lines in Unit 3, we did some certain things with them. We found, and one of the things we did was find the slope of a line. Well, we're going to use the slope of a line again, but because we're talking about actual situations now, like if we go back to that pizza topping example on the first page, okay? I mean, that's technically not a line, but it forms a line, okay? Which means we could find its slope, but we don't call it the slope of like pizza toppings, okay? We call it the rate of change. So rate of change is actually the same as slope. You find it the same way. So to find the rate of change, it's calculated by dividing the change in the independent variable by dividing the change in the independent variable, sorry, dependent variable, by the change in the independent variable. And remember, the dependent variable represents the y's. The independent variable represents the x's. So we're dividing by the change in the y's by the change in the x's, which is the slope formula. How do you find change? You subtract. So really what we're doing is we're using the slope formula, but we're just using different, we're not using m to calling it rate of change. So we're going to use this formula, but instead we're going to call it the rate of change. So let's go back in the example, when I say in our example, I'm talking about the pizza toppings. Let's go back to the pizza toppings. Give me one of the points. Sure. Do you want to, how about the ones without the decimals? Do you want to use those ones? Because those would be easier. So we could use, because it doesn't matter which 2 points you use, the rate of change is going to be the same. It has to be, because it's a line. So let's use 0 and 5, and 4 and 8. I mean, you can use the ones with decimals, and those, like I said, it'll still work out. So I'm going to call this the second y minus the first y, 8 minus 5, over the second x4 minus the first x0. And we get 3 over 4. Now, when we were talking about slope, we would leave it as a fraction. Okay, but we're talking about an actual situation here. So when we have these things, we actually want to go to decimal. So you would want to convert this to 0.75 because there's units. What are the units? Well, the units is the dependent variable per independent. So remember, the dependent was the cost per, and then 1 unit of the independent topping. So you need to put that as part of your interpretation. You need to put the units. So like if we did your pay and the number of hours worked, to find the rate of change, the units would be dollars per 1 hour. Cost per one topping, or just topping. Okay? Miles per 1 hour, or kilometers per 1 hour. And like I said, we can choose any pairs of independent and dependent variables. The rate of change will always work out to the same value. So like I said, we could have used the decimal ones, 2 different ones, and you're going to get the exact same answer. Because like I said, it has to be. It's 75 cents per topping. It doesn't change. It's not like when you hit 4 toppings, it's 50 cents. It doesn't change. So if we know the rate of change, we can actually find the equations of these kind of linear relations. So when we were just doing lines in general, okay, to find the equation, we use this formula, y equals mx plus b. Except now we're going to use different words when we're talking about an actual situation. So remember, y is the dependent variable. So whatever the letter for the dependent variable is, equals, instead of m, what do we call it now? Rate of change. And we're going to put that in parentheses because we're going to multiply it by the independent variable. So m is the rate of change, x is the independent variable. And instead of b, we're just going to call it plus what? Plus the initial amount. Or in other words, the amount when the independent variable is 0. Okay? So if we take this formula and apply it to the pizza toppings, we got to assign each variable a letter. What would you like to call the number of toppings? What letter? Sure, little n. And usually with cost or time, we usually use a capital letter. So let's use capital C. You don't have to write that. You can, because we're going to put it here. So the dependent variable is cost. Well, we're going to call it capital C. What was rate of change? Well, we calculated it to be 0.75. Times the independent variable, which was the number of toppings, which what we decided to call n. Plus the initial amount. How much did it cost for 0 toppings? How much was the pizza? $5. That's what our equation is going to look like. Okay. So let's practice with the last example. It's this. And it's actually 2 situations. because we've got two graphs. Are these situations going to be linear? Yes, because if you look at the graphs, they form a line. Okay. Notice these ones are connected. Why are they connected? Because you can have part of time. You can have part of a minute. You can have part of a liter. That's why they're connected, whereas the ones we did with pizza toppings weren't connected because you couldn't have part of a topping. So we've got two situations, both with the same independent and dependent variables. First one shows water filling up in a tank. Second one shows water emptying in a tank. Okay. Well, what are the independent, what are they, what's the independent one for both of these graphs? How do you find it? No, it's always the x-axis. Independent is x. Dependent is y. Time and dependent is volume. Because the volume of the tank depends on the time. It changes depending on how much time has gone by since it's been filling or emptying. And that's for both. It's the same for both. And then we're asked to find the rate of change for each linear relation and describe what it represents. So for, let's call it A, we'll find the rate of change, and for B. Remember, to find the rate of change, that's the same as slope. So you need 2 points. Let's look on the graph A for 2 points. Looks like we got lots to choose from. Because there's one shown here, 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 here. I like to use this one. Why? Because it's both zeros. It's easy to work with. So I definitely would like to use this one. And then pick one of the other points. It doesn't matter which one. I'm going to go up to this one because it's pretty easy to read because it says 84,000. So remember, second y minus first y over second x minus first x. So we've got, I'm going to call these the second ones. So 4,000 minus the first y 0 divided by 80 minus the second y 0. That gives me 4,000 over 80. Which works out to 50. What are the units? How do you say the units? You need both units. Remember, change is a rate.
Would it be 50 liters per minute?
Exactly. 50, and then whatever the dependent variable is, liters, per one of the independent, or 1 minute. For the second one, well, we don't get to use 0, 0 for the second one. Which ones would you like to use?
6,000.
Okay, so 6,000. 42,000. And like I said, it doesn't matter which one we call which. We can call these ones the second one or the higher one the second one. It's still going to give us the same answer. So I'm going to do this minus this over this minus this. So I'm going to do 6,000 minus 2,000. Over 0 minus 40. Which gives me 4,000 over negative 40, which works out to negative 100, and it's the same units, right? Liters per minute. So we're asked to state which one each represents. Okay. What's happening? Like 50 liters per minute. What's happening at 50 liters per minute? Right. Tank is being filled at 50 liters per minute. What's happening with the negative one? Right. So the tank is being emptied, but don't write negative 100 because that doesn't make sense. It's being emptied. When we write the word emptied, that means negative. So it's actually being emptied at 100 liters per minute. Because if you think about it, if you use logic, if you say it's being emptied at negative, that means it's being filled. I know it messes with the mind. Let's just, I know this isn't part of the question, but I would like to find the equation for A. Just so we're comfortable with how to find equations. What's the remember, it's dependent variable equals rate of change times independent variable, whatever the letter is, plus the initial cost. What's the letter that's used for the dependent variable? L equals rate of change, 50, times time. What letter is used? And look at the graph. No, what letter is used? Oh, here. Yeah, L isn't used, B is used, and T is used. So I'm using those ones. So this should be B. Equals 50T. But what's the initial amount? When time is 0, how much is in the tank? Look at the graph. 0. So there's nothing to add. Right? So that would be our equation for this relation. Notice we're not using y and x. We're using the variables from the actual situation. Okay. Okay.